enough. We started with a simple conversation. So imagine it's election day. 30, 40 million people showing up to vote. What our software does is allow them register these people, check for duplicates, or if there are any signs of fraud.
Can we have a loyalty program where an average person can earn points every time they shop for groceries, and this currency effectively becomes a second source of wealth to pay for everything from your electricity bill to school fees and doctor's bills?
Two of my cousin sisters suffer from breast cancer, and I ended up losing them. That's when I thought, we need to do something with technology to build a new way of doing breast cancer screening.
In my graduate school, I was one of 2 women in a class of 45. And it kind of got me thinking that this is not what it's supposed to be.
We have this patient called Maria. She's 6 years old, and she was having these daily seizures. She lived in a remote area in Brazil where there's no specialists, and no one in the city could help her.
I'm a developer during the day, but then during the evening I wear my cape and I do Google stuff.
One of the things that are most amazing is being on Google Cloud has enabled us to be online and available 100% of the time with automated health checks, security checks, and logs monitoring. I use tools like Stackdriver to keep me on top of all of that.
Google and the Android platform have become kind of a backbone of our entire product ecosystem, where we could actually build this loyalty program powered by mobile phones.
We use deep learning and the technology stack called TensorFlow to interpret thermography, which basically measures the temperature on the chest and then figures out if there is any abnormal tissue activity. And this can be 5 to 8 years before a lump is formed or felt.
We're actually helping people to get access to doctors that they couldn't have without the stack. For example, this case with Maria, with Google Cloud, we connect to the clinic device, measure Maria brainwaves, send to the best child neurologist in the country, 3,000 kilometers away in São Paulo, and she found the cure for Maria. And this was awesome.
I run the Google Developer Group Vancouver chapter. I see girls from high school, they actually show up at our meetups. They know nothing about the product, and after like 1 hour or 2 hours of time, they can build something from scratch.
I'm one of the co-organizers of GDG Cloud London. We are the most active GDG Cloud community in the world, and I love how you can achieve all these dreams and passions and ideas you have using the Google Cloud platform.
Whatever you do in life, try to solve a meaningful problem.
More than ever, people are asking for purpose on the work that they do.
You're not just building product, you're building product that can change people's lives.
My hope is that we will excel in technology. Women will get their seats at the table.
I feel that Google just empowered me.
From that moment, it's been love. That's pure love.
Please welcome to the stage, Eva Fours.
Good morning, everybody. Welcome to day 2 for those of you that are spending the full 2 days with us here at Google Cloud Next. And a special welcome to all of you that are here for the first day. We have thousands of developers and startups that are spending the day together here with us. Day 2, we will dive into what it means to bring the cloud to you. We put customer success at the epicenter of what we're doing. And this morning, you will hear how this can also become your reality. It's intuitive, it's global, it's designed to work the way you want, and where possible, powered by AI, so you can be more productive and you can maximize the usage of your data, which is by far your absolute biggest asset. There's a lot of wording talking about data, the new currency, oil. I found a much better wording. So data is the sword of the 21st century, and those who wield it well, the samurais. Who of you don't want to be a samurai? Talking about data, GDPR has been a major focus for all of us, both you as customers and partners, and also for us here at Google Cloud. To support you in your efforts, we have published a very extensive GDPR resource center for you to provide a reference to the contracts, to the terms, and everything about our products and services. At Google, we are passionate about data, and this morning we will share with you how you can unleash these superpowers through our platform. And we will talk about what's new in the infrastructure, network, developer tools, and operations, and what we do with AI. We'll talk about what we're hearing from customers and what we have built to meet their needs, what we're doing next on our network, the world's biggest enterprise network. And we have been adding a lot of new cloud regions, as you heard yesterday on the keynote speech. And I had the fortune to be in Helsinki in Finland just a few weeks back. We were launching a new region. And this region can improve latency for Nordic customers for up to 65%. And latency can be decreased for up to 88% if you are based in Eastern Europe. So this is an amazing opportunity for you to go on cloud, leveraging all these new cloud regions. We will also talk about tools for migration and serverless, how we are building the best DevOps environment. It's open, it's accessible, and built to balance speed with quality. We're passionate about customer success, and as Diane Green mentioned in her keynote yesterday, we take pride in co-developing services side by side with customers, and where our end-to-end collaboration is unique. For those of you who were here yesterday, you heard Åsa Bredin from King talking about how we have been co-developing side by side. And this is what day 2 is all about. There's something else I want you to think about, as we have talked more about yesterday's big message, bringing the cloud to you. Yesterday you heard about G Suite, our collaborative platform. An important thing to think about G Suite, that even though each different service is great, the sum of its parts is so much better. So G Suite features lets you seamlessly go from spreadsheets to slides to doc to starting a chat to a video conference. Everything powered by AI. Simple, smart, secure. We have an unsurpassed global network of data centers with millions of servers globally spread. But they're also a guarantee of performance, security, redundancy. And we have things like global databases using satellites and atomic clocks to make sure that your data is aligned at the microsecond, if that's what you need. All on a proprietary network that is more than just a lot of fibers. It's the fastest and the most secure network. And with open software that's delivered to the services and the business insights, open source for the larger community. And with Google, everything, and I mean everything, is on containers. We are launching more than 4 billion containers every week. That equals 396,825 containers every minute. That's an impressive number. In 1 minute, we are launching 396,825 containers. So we know what it takes to run really, really large-scale infrastructures. And to take you into one step deeper, I am really excited to invite to the stage a true legend to this stage. He's been around since Unix, Linux, way back in the 80s. And he joined Google as Vice President for Cloud Platform in 2014. Give a true rock star applaud for Brian Stevens, Chief Technology Officer of Google Cloud.
Thank you, Ava. Way back into the 80s. Yep. Now a bit of gray hair. Good morning, London. I'm Brian. I'm here today to talk to you about the core of Google's cloud business. And our business is actually you, our customers. And the reason is because our customers are the single best lens to understand what we do, and even more importantly, why we do it. So as a technologist, I've always been passionate about technology and creating things that you couldn't create before, and that's amazing what software can do these days. But to be able to actually solve new problems. But the measure of success, even for a technologist, isn't what about the technology itself. It's actually what you unlock for customers, because you're trying to make a step change impact for your customers. And so we actually gain a lot of knowledge by working so closely with our customers, and it actually keeps us from building technology just for technology's sake. And it really can, you can create these, move what's typically a customer-vendor relationship into a true partnership, in pursuit of solving new endeavors. And the relationship, I always hear this a lot at Google, it's not a cost of sales relationship, it's a relationship about strategic endeavors, and it makes both of us better. So what I want to do is I want to start off by giving you a few highlights of some examples of what I mean. So Google Cloud Bigquery was actually called, and still is called, Dremel internally inside of Google, and it's what we use for full-scale web, weblog analysis. But today in healthcare, we're using Google Cloud Bigquery, and what we're doing with it is we're actually creating a clinical analytic data warehouse. So we're actually taking patient records, and we're streaming ingesting them and combining that with scientific research. And what that's doing is creating this collaborative shared platform between the scientists and the researchers and the clinicians that are administering patient care. So it's really powerful. In financial services, risk management and anti-money laundering are really crucial for that market for financial safety. But in supporting that, though, it's super expensive for the enterprise firms. So what we're doing is we're actually ingesting with Google Cloud hundreds of petabytes of transaction data and risk data. And already we're having an impact on both increasing the risk for the financial market, decreasing the risk for financial markets, as well as decreasing the costs. And then in retail, we're using Google Cloud, BigQuery, and Kubernetes Engine. And what we're doing is we're actually able to model and predict what's happening on shelves, because what you want to do, obviously, is avoid outages. But the prediction around that is non-trivial. And already after some short trials, we're having positive results on same-store sales, which is really amazing that cloud technology is applying to brick and mortar also. So machine learning for vision, one of our first machine learning algorithms used in applications like Google Photos. Now we're using it in the energy industry as the world tries to explore and find new sources of energy. And cloud technology has no boundaries just on Earth. We're working with the Frontier Development Lab and NASA, and what we're doing is we're actually analyzing the algorithms that are actually trying to find new planets and life outside of our solar system by processing all the data that's coming off of these satellites. And already, after just a few months, we've increased these models and algorithms to greater than 96% accuracy. So it's pretty amazing that Google Cloud's going to help us find new planets. So building technology and working directly with customers, I think that's, as a technologist, that you get the best of both worlds. And so to scale that, we actually created a specialized group inside of Google called the Office of the CTO, or OCTO for short, and they focus on exactly this. It really feels like we're in this new era. We're at this time where we're solving problems that mass-produced mainframe servers and commercial off-the-shelf software of the past just couldn't solve. And the best part about it for me and for my lineage is that we're actually doing it openly. Years ago, we made a commitment that we were going to make Google Cloud an open cloud. And today, here we are with things like gRPC and Kubernetes and Linux, Hadoop, Apache Beam projects, and TensorFlow. And the reason is because open creates a compatibility and integration with Google Cloud with other environments, but also with a really broad tool set. So it's really valuable not just to us and our users, but the entire industry. Second is open actually allows us to work with our customers, not just at the edge and the periphery of cloud. It lets us work with them deeply within the core of Google Cloud, so it's really powerful. So we all know that open source is wonderful, but it's actually great at solving new problems and driving new de facto industry standards in areas where the industry solely needed it to move forward. But it's also equally important to embrace existing industry standards. And so what we've been doing with Cloud Spanner is making it easier to read-write data using industry standard SQL. So you'll definitely see that Google's got a hybrid strategy in how we think about open and existing standards. So I speak for the entire engineering community for cloud that their #1 priority is understanding your problems and solving your new opportunities. So Google Cloud's moving really fast. So over the next 70 minutes, me and my colleagues want to give you the latest updates. So Google Cloud is more than just a collection of data centers. It truly is a global software-defined platform designed for resilience, security, efficiency, scale, and quality of service. It truly is the new global computer. And it's growing really quickly, as Ava was saying. In the last 24 months, we've added 12 new cloud regions around the globe so that you just have really great choice of where you store your data and where you want to run your workloads. So now we have a total of 17 regions, including our new, most recently added regions in Finland and Los Angeles. So you most likely are able to store and run where you want to. And we aren't done because Hong Kong is going to be coming online soon. But delivering your services, though, actually requires more than just a distributed global set of data centers. So with Google Cloud, you have the opportunity to leverage over 20 years of innovation that has really transformed the networking industry. From world-class fabrics that we use to connect to services within our data centers, to the first production software-defined network that connects our data centers together, and to a really powerful edge of the network that runs across 125 points of presence around the world. So our customers and partners aren't segmented from this. They're able to connect their data centers and their network directly into us, Google Cloud, how they choose, with VPNs, with peering, or with interconnects. So our Google's global network delivers the security, the performance, and just this high quality of experience. And we deliver it as a service so that we run the network for you so that you don't have to. So scale, resilience, performance, they're all incredibly important. But the first priority for you and for us is security. And as Diane mentioned yesterday, Forrester recently named us as the leader in their public cloud security evaluation. It's a really great report. It's really long, but so I encourage you to read it, and you'll really be able to understand the depths of our security capabilities. I'd also be remiss, in Europe, we spent a lot of time working on GDPR. It's really important. So meeting the compliance was a great milestone for us, and it adds, it's great for users. You add GDPR together with what we're doing around encryption for data at rest, data in flight, and it really puts the users of Google Cloud in total control of their data, which is very important. I actually spend a lot of time with regulated industry, and especially financial services, and what you hear from them is that they really understand that the security of Google Cloud is very advanced, more advanced than their own. But one of the challenges they have and how we actually work with them is how do we take the security capabilities that we have and how do we integrate it into their existing control and control planes? And as we do that, we want to give you in the more telemetry. Even though Google Cloud is a bunch of managed services, you really want to understand what's happening inside. So it's very important. One way we do this to help is by enabling the software and the capabilities around security that you already use and make them work in Google Cloud. So today, we're actually announcing the beta of CloudNAT, Network Address Translation. And what that will do is what you expect. It allows you to keep your GCP deployments completely isolated as you would like, and then control the access that they have to the internet. And in Google fashion, it's not a hardware-based thing. It's software-defined. So there's no middle proxies. There's no choke points, so you get full-on, straight-out performance. A second way we help protect is against malicious attacks. And so we have a Cloud Armour service, and what Cloud Armour does, it actually automatically defends your internet-facing applications against DDoS attacks. And it leverages the same global infrastructure that's built to defend against terabit-level attacks that we use to protect services like Gmail, Search, and YouTube. So to show you more about Cloud Armour, I'd like to welcome Prajakta to the stage.
You have a tough job. You want to quickly and responsibly serve your users, and at the same time, you need to defend your internet-facing services against malicious attacks. This is where Cloud Armour comes in. Let's look at a live demo to see how Cloud Armour defends against SQL injection attacks. Now, with SQL injection attack, one little flaw in one little feature of your app is often all it takes to compromise all of your data. Let's take a look at the screen. We're going to launch a SQL injection attack using a tool called Metasploit. What you're seeing here is a live attack. Now, what would happen without Cloud Armour? You would have to first detect SQL injection, and then react, remediate, and also fix your code and data. Let's switch over to the GCP console, and let's see how Cloud Armor fared under this attack. Let's start with the logs. You can see that Cloud Armor has blocked all SQL injection attacks using the policy that you see on screen. Now let's look at our Cloud Armor policy. All you need to do is to configure one single rule to block all SQL injection traffic. When you enable this rule, Cloud Armor looks for over 160 patterns under the hood to identify and block SQL injection attacks. Let's look at a different attack. We are going to launch an HTTP flood attack. Now, when you're facing an HTTP flood attack, you will see a sharp rise in page views and a sharp rise in requests. Unfortunately, this isn't good news. Why? Because your business metrics, such as orders placed and your dollars spent, will continue to decline. Let's take a look at the screen. We just launched a live HTTP flood attack. You will see a flood of HTTP packets from all over the world. Now, without Cloud Armor, you would have to first detect this attack and then continue to add capacity to absorb this flood. Let's switch over to the GCP console and see how Cloud Armor fared under this attack. Let's start with the logs. You can see that Cloud Armor has blocked all HTTP flood attacks using the policy that you see on screen. Let's look at our Cloud Armor policy. You can see that the IP addresses which were generating the HTTP flood are blacklisted dynamically. How did that happen? These IPs were automatically identified by our Bigquery ML service and then fed into this Cloud Armor policy, thereby keeping your services safe, up, and running. What you really get with Cloud Armor is actually much more than this. You get defense at scale using Google's massive global and edge infrastructure. And of course, in keeping with our openness, Cloud Armor's open rules language allows you and our security partners to build sophisticated custom defenses. Thank you. Back to you, Brian.
Thank you, Prajakta. So most of you, like I said, already have a bunch of investments in networking and security solutions already, and that's why, working with our partners, we really spend a lot of time making sure that those solutions that you deliver still work when you use GCP. So we'd like you to be able to migrate to GCP. It's a very magical place. We don't want you to use tricks. We look for ways to decrease the friction as much as possible. Often what I see is two paths to that journey to adopt GCP. The first is really a cloud-native path, taking advantage of containers and Kubernetes and Istio that we heard Ors talk about yesterday for a really obvious set of benefits. But another way that we've seen is that customers that aren't able to spend the investment time into their application stack and don't want to rewrite things to be able to take advantage of the core of GCP. And so most customers are actually doing a bit of both based on the use cases that they have. So to make this lift and shift case easy, we provide the Velastrata service. And Velastrata is all about is how do you actually migrate applications without modifying the application stack with as little downtime as possible. And we can do that today on GCP with under 10 minutes typically of downtime. Your critical data is your intellectual property, and implementing its durability and its availability is actually a non-trivial task. We wanted to make that easier as well. So today we're announcing that we're giving you more control on some storage capabilities that are going to make that easier for you. So the first is a dual regional option for cloud storage. And so with dual regional, you can take your storage buckets and you can actually co-locate your compute with your GCS storage. But yet you can still benefit from the redundancy by having your storage replicated into a second region. Second, our nearline and cold line storage offerings now offer Geo Redundant Replication. So what that means is you can actually have more than one site, 2 copies of your data more than 100 miles apart, which is really valuable, all at the same cost that you already have today. And because they both leverage the high speed of the Google Cloud Network that we already talked about, it's geo-redundant storage, but still at millisecond level latency. So now I'd like to actually invite Derek Lyon from Twitter, a company that we're really fortunate to be able to work with, to tell you about what they're doing with Google Cloud. Love the blue. Hi, Derek. So let's get started. Tell us what you're doing with Google Cloud.
Yeah, so Twitter operates at a massive scale with a relatively small team. We found that ad hoc data analysis is an area where we could benefit from options in the public cloud. For example, to detect patterns of abuse, to see how people are engaging with the conference's hashtag #GoogleNext18 or Brexit. To support this, we're moving several large-scale Hadoop clusters to GCP. And I'm serious when I say large-scale. In total, we're migrating about 300 petabytes of data. These clusters are primarily used for cold storage and ad hoc analysis, and constitute only a small portion of our overall infrastructure. But we think of this as a very important learning opportunity for us.
Awesome. So we know there's other clouds out there. We know we're the best cloud. But how did you figure that out, and how did you decide to use Google?
Yeah, so there's obviously a lot of factors that go into a decision like this. Three, I think, are probably most relevant. The first is performance. So we did an in-depth technical analysis over an extended period of time, actually. And we found that Google Cloud performed the best for this ad hoc use case. The throughput of GCP's network and storage systems was the primary reason for that. In fact, we found the network performance is good enough that we could actually separate compute and storage, which is an architectural option that gives us a lot of flexibility. Second was efficiency. At our scale, costs can really add up. We have deep technical teams that drive optimizations across the stack, and we found that we were able to avoid resource stranding by using custom VMs on Google, as well as a number of other efficiency wins. Lastly, any choice of this kind requires a prediction into the future. The Google team's culture, their focus on security, and their commitment to open source all give us confidence in the future of this partnership.
Love it. You hit on so many points that are sort of near and dear to engineering. Yeah. So one of the things that we talked about earlier was really making Google be customer-centric. And so what you didn't hear earlier is that whole dual regional concept for storage was really driven by our relationship with Twitter. So be helpful to tell people like how you're using dual regional. Yeah, so we're going to be using dual region buckets for our data platform. They provide us with the ingest performance and multi-regional availability of multi-regional buckets, but with the data locality of regional buckets. So one of our first use cases, which demonstrates the value of this, is a recent large-scale log analysis project that we did. For this project, we needed to run interactive SQL queries over 15 petabytes of compressed log files. With dual region buckets, we were able to ingest the data using our 800 gigabit per second of connectivity, which spans multiple locations across the US where we have peering with Google. For the processing of the data, we're using a large ephemeral Presto cluster running on Dataproc, which is able to process the data at an aggregate throughput of 4 terabit per second for a single query. That enables us to interactively query such a large data set. We worked closely with Google in order to tune this cluster and to be able to scale it to that level. And the ability to process data at that scale while still having this multi-regional availability is a big part of the reason that we like the dual region buckets. This is obviously just an early use case for us, and we look forward to sharing more as we continue our migration. Awesome, we're looking forward to it too. So I know our business teams are loving that Twitter's now on Google Cloud, but our engineering team really loves the interaction. It's been fantastic. Thank you so much. So it's always been amazing to me what you can accomplish when you take such a strong technology portfolio, deep engineering talent, and you take that and you meet your customers where they are and you really work closely with them in a meaningful way. Aligning goals and collaborating towards those goals really can produce meaningful impact. Google actually recently turned 20, and our legacy in infrastructure and networking and security, SRE, analytics, machine learning, that legacy has actually created our competitive advantage for cloud. Many of you have your own legacy. Legacy is not a burden, it's an opportunity. So we look forward to working with you to turn your legacy into your competitive advantage. Thank you. So now I'd like to invite my good friend and colleague, Amiel, and he's going to talk to you about how Kubernetes and Istio are really changing the lives of developers.
Thank you for joining us today. I've been in Google for 11 years, and I've never been more excited about cloud services platform than I am today, and I'll share more of what Urs spoke about yesterday. You know cloud computing can help speed up your IT and improve security. You want to create software faster, and you want to integrate all the investments you've already made together. And you want to do that in the cloud, or on-premise, wherever you are. You're looking towards the future. There is a lot that's needed to make it work. We hear you. And that's why our team has been working really hard to create the Cloud Services Platform. CSP is a hybrid cloud software for application modernization. So let's dive right in. Containers are the universal language of the cloud, and Kubernetes is the way the industry has chosen how to orchestrate them. Istio is an open source project that is the way to connect and secure containers and microservices seamlessly. Cloud Services Platform starts with a managed version of both, integrated to work together. This is not a kit. No assembly is required. We've done it for you. CSP is based on Google's Kubernetes engine, the industry-leading solution we launched 3 years ago to bring you managed Kubernetes. CSP lets you build and run your applications anywhere the same way, on-premise, in the cloud, or hybrid. It's your choice. It provides a consistent open API across those environments. And open is important for you. And the reason is it gives you the portability you need to be future-proof. CSP does a lot of the work for you with built-in monitoring, one-click secure deployment, and smart cost management insight. Your operation teams can be a lot more efficient and effective. It automates rapid releases and provides auto-healing in case of issues. With Cloud Services Platform, our vision is to let you move up the stack to realize huge productivity gains from using higher-level abstractions. Today, I'll share some more capabilities of the Cloud Services Platform. We'll tell you how we're securing containers and deployment pipelines. We'll share more developments on the emerging container-based ecosystem. In July, we released Istio, a way to put together the mesh of services that make up a modern enterprise application with no additional code needed. Istio gives you detailed metrics about service-to-service communications, load balancing, auto-failure recovery, authentication, end-to-end encryption, and service discovery. CSP lets you administer security, identity, policies centrally and consistently across hybrid environments. It brings the Kubernetes operating model to your hybrid cloud. One comprehensive policy for all of your IT. We've been doing this at Google for years, and we took a lot of those learnings to create Istio. We've also integrated Istio with Apogee's industry-leading API management platform, so you can make your services available to developers inside and outside your organization seamlessly. To help show what Istio can do for you, I'd like to welcome Mandy Waite to the stage.
Thank you, Eyal, and hello, London. I want you to imagine that we're an e-commerce company, and we've developed our new site as a cloud-native application, initially with about 10 microservices. Some of these services are written in Go, some in Python, some in Node.js, and even one in C#. Each dev team has selected the most appropriate language for each of these services, and a polyglot microservices architecture is very easy to implement on top of Kubernetes. Our online store sells everything the hipster needs, and our imaginary CTO of our imaginary company is now going to demonstrate this for us.
So I'm looking at the hipster app here, and I can see everything that a hipster could want. I think I'm going to pick up one of these cameras. Those look great. Add that to the cart. And you know, I still have a big collection of vinyl at home, so I'm going to grab one of these vintage record players, too. This is indeed a hip e-commerce site.
Thank you, Dan. Now let's look into the Cloud Console, where we can see that this application is actually running in Google Kubernetes Engine. Now let's install Istio. We want to do this to get better observability and to run our application more reliably. Also, we want to improve our security posture by using service-to-service security. Istio enables us to create a strong service identity, which can then be used for authentication and authorization, as well as transport encryption between all of our services. Istio is now installable, automatically installable, on a GKE cluster. And once installed, Istio components are automatically updated when GKE is updated. You can install Istio when creating the cluster, or even once the cluster is up and running, as Dan will now demonstrate.
So I'm going down to the add-ons, and I'm going to enable Istio. And I will also, for better security, enable MTLS. I save it, and Istio is installing.
Well, that was pretty easy, right? So after a rolling restart of each of the application components, Istio will take effect. So traditionally, configuring encryption on your application firewalls would mean you have to create certificates, make a plan to roll out all of your updates to dozens of application firewalls, and then spend months executing that plan and verifying the deployment. In contrast, it will normally take about 3 minutes to install Istio to a GKE cluster. And I think we're going to save these 3 minutes because dead air, 3 minutes of dead air is not good, by going to a cluster that Dan installed Istio to earlier. We've now deployed Istio into the cluster and automatically enabled mutual TLS between all of the services. That's right. We've deployed Istio into the GKE cluster that's already running the Hipster Shop application. We can now configure Istio to start monitoring and controlling the traffic, service by service, namespace by namespace, or in this case, all at once. If we click into any of the application services, we can see that the Istio sidecar proxy has been added to the service.
Looking into my pod, I can see that Kubernetes automatically injected the Istio proxy, and that is now processing all of the calls into and out of my service.
That's awesome. That was really easy as well. Okay. This sidecar proxy is enforcing mutual TLS on every call, making our app even more secure. It's also gathering telemetry and logs from every single call on the mesh. Now that we have Istio installed, we can monitor our application just like a Google SRE, as Istio is now gathering the golden signals for our service. We can see traffic levels, including what traffic is coming from what client. We can see latency at the 50th, 95th, and 99th percentile. And we can see details of any errors that may have occurred. In this case, we're using Stackdriver, which is automatically integrated with your cluster. And we can use it to set and monitor SLOs, as well as alert us if we're not meeting those SLOs.
We can also view interesting visualizations. For example, here, Stackdriver is displaying a heat map of the latencies of my different services in the mesh.
OK, so in summary, we did all of this. We made our app more reliable, more secure, and we did all of this without any interruption to the running application, allowing us to continue servicing the needs of our happy hipster customers. Thank you, Dan. Back to Eyal.
Thank you, Mandy and Dan. As you saw, the visibility of Istio provides you into your app, will give your operations team everything you need to keep it up and running, and that's the fastest I've seen securing microservices. Customers like AutoTrader UK, Descartes Lab, HSBC, and MasterCard are already working with components of the cloud services platform technology stack. The feedback from early customers working with us on CSP has been fantastic. One of our early customers, KeyBank, told us, put simply, the cloud services platform provides us the security we need, the portability we want, and the productivity our developer crave. We announced the release of Istio 1.0 less than a quarter ago. Since then, we saw a 75% increase on Istio usage on GKE. And all of those customers had to work a little bit hard to install it manually. But we're about to make it even easier to start using Istio. I'm also pleased to announce that we will be the first cloud to bring you Istio integrated to your cloud environment. This will be available in beta next month. With the release of Istio add-on on GKE, you can have protection of data encryption to your services that communicate with one another. You'll have network traffic observability, active traffic management, all with a simple command line or checkbox, only available from Google Cloud. No code is needed. It's just a simple config. One thing we hear over and over from you is how important security is for container adoption. Organizations running containerized workloads also need to ensure that only trusted code is deployed. This is why we have released binary authorization, Binary authorizations allow images to be signed by a trusted authority during the development process, and the signature is validated just before deploying them in production. After security, the next requirement we hear from you is development agility. Isn't fast always better than slow? Modern development is shifting to event-driven microservices and serverless. Event-driven computing and serverless allow developers to focus on the business logic rather than the repetitive tasks day-to-day that have very low value. In the last year, we've seen a 10x increase in the beta use of cloud functions. So we are thrilled to recently release cloud functions to full general availability with an SLA-backed offering for production use. We're going even further, though, as some customers have asked for more flexibility to bring your own runtime, languages, libraries for execution, so we're adding container support to cloud functions later this year. Serverless can be so much more than running code snippet in the cloud, though. Customers are asking for benefits of serverless anywhere without lock-in. Recently, we introduced Knative. Knative is a new open-source project that brings serverless building blocks into Kubernetes. This ensures workload portability and consistent capabilities across clouds. We've developed it in partnership with Pivotal, IBM, Red Hat, SAP, and many others in the community. Moving forward, Knative will be the basis for unified and portable serverless environment for the whole industry. We're also making it fast and easy to incorporate third-party services and software from the hundreds of partners and vendors you rely on. To make this easy, we're offering a new way to deploy container-based software using a single click. And it's all managed automatically through the Google Kubernetes engine. Before today, enterprise had to pull the image, implement the solution independently, and separately negotiate licenses or subscription fees. And even then, the containers may not have been properly maintained or deployed, and we all know how painful that can be. We're addressing that with being the first public cloud marketplace to offer commercial applications that are deployed easily through Kubernetes engine. The Google Cloud Marketplace has many partner solutions that are viewed millions of times every year. So by adding applications ready to deploy on Kubernetes, we're now giving the same easy procurement and vetted supported solution, all with a simple usage-based pricing that you have come to expect. Let's see it in action. Starting with Kubernetes engine, you can discover solutions in the GCP marketplace. Once you select an application, you can click to deploy quickly with the Kubernetes engine cluster. While it's configuring, everything is built through one single unified cloud build. And for partners, launching Kubernetes containerized applications on GCP Marketplace is faster and easier to maintain. And now you can see our site is live. That's pretty much it. Thank you to all of our partners who have joined us in the Kubernetes space. I'm excited about the application we have today, and I look forward to seeing many more solutions by the end of this year. So go to GCP Marketplace and try out some of our partners' offering. The transition to cloud computing can help speed up your IT, improve your reliability, can make your security and compliance much easier, and it can open up new business options for you. But to make this transition, you need a comprehensive cloud platform. You need to ensure you have the ability to create software faster, to operate it securely, to carry forward existing investments that you depend on, and extend those investments through a vibrant ecosystem. Kubernetes, Knative, and Istio are all based on the experience we have in Google building applications for over a decade. And now, they provide the foundation for the cloud services platform. We can't wait to see how you will use it. One of the best ways to use cloud services platform is in conjunction with modern sets of DevOps and practices. I'm pleased to welcome my colleague, Melody McFessel, who leads the Developer Tools engineering team. Thank you.
Thank you, Eyal, and happy birthday. Today is Eyal's birthday. So, my name's Melody McFessel, and I'm passionate about developers because I am one. I also worked in operations for many years where I carried a pager, and I became very familiar with the phrase, if it compiles, let's just ship it. Today, I lead developer and operator tools at Google, including Google engineers, Chrome and open source developers, Android developers, and developers using Google's cloud platform. Now, each of us may have a somewhat different definition of DevOps. At Google, our understanding of DevOps is based on two key areas. First, end-to-end automation from source, build, test, to releasing with integrated observability. And second, a culture to support the developers and operators. DevOps is near and dear to my heart. It's about automating the way the toil so that we can spend time on the things that we love. And hopefully it makes us a little bit happier. So happy developers and operators translate to better business outcomes. Industry research shows that elite DevOps teams are more likely, 1.53 times actually, more likely to meet or exceed their goals. At Google Cloud, we've realized that developer and operator happiness is predicated on automating repetitive manual tasks away, thereby increasing our velocity while improving quality. And with the right DevOps tools, elite DevOps teams are able to release code 46 times more frequently than their low-performing peers. They're simultaneously keep their production deployments are 7 times less likely to result in a degraded service. So think about that. You get speed with quality. However, choosing the right DevOps tools, it can be difficult. It's time-consuming and unproductive. Our goal is to make DevOps tooling decisions easier for you, irrespective of whether you're a developer trying to ship as fast as you possibly can or an operator trying to maintain the stability of your service. So to help operators quickly investigate and respond to issues affecting production, I'm excited to announce the alpha launch of Stackdriver Instant Response and Management. Yay! So IRM provides site reliability, incident response processes, and best practices from Google for efficient coordination and collaboration. IRM uniquely highlights monitoring information based on the context and the environment of the incident to help you diagnose issues quickly. We've been using IRM at Google for services accessed by billions of users. And to highlight the impact of Google's SRE principles driving IRM, please let me bring David Ferguson, the Amiel lead for customer reliability engineering, onto the stage.
Morning, everyone. Thank you, Melody. As Melody said, I head up the customer reliability engineering team based in London that covers our customers in EMEA. But I've also been on call at Google. I've been on call for Cloud Data Store, which serves millions of queries every second of every day. When it comes to on-call, we need coverage for critical services. We want to make sure reliability isn't being achieved at the expense of an on-caller's health. What on-callers really require boils down to us simplifying 3 things. Simplifying the input as new information flows in. Simplifying the processing as on-callers work to resolve the issue. Simplifying the output so that everybody knows what's going on. At Google, we've developed a suite of tools for on-callers, but we knew we could do better by bringing everything on-callers require into one single place. We simplified the input by showing the alert, a graph of the metric that triggered it, and making it easy for on-callers to combine related alerts. We simplified the processing by providing links to documentation, insights into metrics correlating with the incident, and easily allowing on-callers to bring in other people to help out. We simplified the output by making it painless to provide updates to everyone as you investigate and resolve the issue. The result of that effort is IRM, our next-generation platform for managing incidents at Google, and its goal is to substantially reduce incident mitigation time.
But IRM isn't just for us. We wanted you to have it too. Best practices are really important for the community. And at Google, we've been sharing more and more about how we do what we do. In 2016, we published Site Reliability Engineering, in which we introduced the philosophy and principles of production engineering at Google. Later that year, we started Customer Reliability Engineering. We work hand in hand with engineers and product owners within our customers to help put these practices into place. And this year, we published the Site Reliability Workbook with the aim of showing how SRE can and is working outside of Google. With Stackdriver IRM, we're going further. We're making the tooling we depend on to manage the process of responding to our production incidents available to you to get on and use. Melody, back to you.
Thank you, David. So let me walk you through an end-to-end DevOps pipeline, including IRM, to show you the DevOps tools we offer today to help you code, build, deploy, and monitor your apps quickly and safely. These tools include cloud source repositories, a single place for you to store, manage, and track your code. Cloud Build, a fully managed continuous integration and delivery platform that lets you build and test applications in the cloud at any scale. And Stackdriver, which is management tools for developers and operators. In the demo, we'll use these GCP DevOps tools with well-known open source tools like Git and Spinnaker. We'll see how proactive, data-driven intelligence in Stackdriver IRM can accelerate investigation into the problem that we're facing. We'll combine that with Stackdriver Profiler to dig deeper into the issue. We'll use code search functionality in cloud source repositories to find the code that's causing the problem. We'll fix the code, we'll commit the change to GitHub, and then we'll kick off a build in the cloud using Cloud Build and check and see if there are any security vulnerabilities that exist. And finally, we'll deploy the build to Google Kubernetes Engine using a flexible pipeline created with Spinnaker. So we'll go from finding the problem, resolve the issue, and push the changes to production in just under 10 minutes. And while we do all of that, we're going to take care of security, and we're going to use deployment best practices. So speaking of the demo, I just received an alert. Our production website, Hipster Shop, is really slow. And to make matters worse, there are a bunch of people that are tweeting about this. The slowness is really affecting them, so it looks like it's a widespread issue. So let me bring Teo, the Site Reliability Engineering lead of Hipster Shop, to the stage so that we can navigate and fix this problem together. Teo, great to see you.
Good to see you, Melody. And as you can see, the website is really super slow. Like, I'm clicking around and nothing works. We really need to get on top of it.
So let's go back to that alert, because it was telling us that latency was outside of the expected range. And if we go to the email and we click on View Details, it's going to take us right to Stackdriver IRM tool. So at this stage, our goal is to reduce the time to mitigate this issue. And IRM's smart. It's given us 3 key pieces of information for us to resolve this problem. First, IRM presents us with a chart of the violating metric and the status of the alert. We can see here that the alert is still firing, so this is a real situation we need to take care of. Second, IRM showcases our team's alerting policy documentation and our playbook. And this contains information on how to handle cases and possibly gives us some suggestions of things to do. And third, unique to IRM, based on the context of the incident and your environment, insights are provided to highlight key information to accelerate the investigation process.
And in fact, in our case, IRM has already highlighted that there's a strong correlation between the latency increase and the CPU spike on our product catalog service. So let's go ahead and open an incident. And once that's done, I'm going to set the severity as major. Here we go.
All right, can you add me as the incident commander on that, Teo?
Yeah, sure.
And before we start digging into the CPU increase, let's make sure that our teammates know what's going on. We're going to add the PR lead and the VP of engineering, and then we're going to escalate the issue so that they're aware of it. So for quick mitigation, we would have traditionally just rolled back to the previous backup. So let's assume that we've already performed that rollback. That way we can mark the incident as mitigated at this point. So we know that IRM highlighted a strong correlation between latency and CPU increases in the product catalog service. So next, we're going to dig deeper using Stackdriver Profiler to understand that CPU increase. So this icicle graph in Stackdriver Profiler shows the resources being consumed by the functions on the horizontal axis and their call hierarchy on the vertical axis. And we can dig in here and we can see that, well, yep, great, CPU time. We need to make sure we select that. So as you can see, we have a very slow gRPC parse catalog method. It's consuming way too much of the service's CPU time.
Yeah, over 80%, in fact.
Yeah, that's way too much. So let's go now and dig into the parse catalog code to see what's causing this issue. So this code is hosted on GitHub, and it's mirrored to cloud source repositories, so we can take advantage of powerful code search and indexing features. So let's search for that parse catalog function that's causing the slowness.
Yeah, and here it is. The search was super fast, and it led us directly to the function that we were looking at in Profiler. And you can see like a dumb sleep function here that we need to fix. So let's jump to GitHub, because I have a pull request already open that's fixing this problem.
Great job, Teo. Completely on top of it. So this repository uses our cloud build GitHub integration, which is really easy to get started with. As long as you have a GitHub repo with a Docker file in the root directory, GitHub will suggest cloud build as the CI tool. So let's go ahead and approve that pull request. And this is going to automatically trigger a fresh build run from cloud build, and we can see that in the UI here.
Yep,
there we go. Great. So Zendesk, Lyft, and over 1,000 plus customers use Cloud Build daily to ship new features and functionality safely and quickly. At Google, we create over 4 million builds in the cloud every day because it's incredibly flexible, safe, and fast. So approving that pull request, this is going to automatically trigger a test build. And the reason we do this is to make sure that that pull request wasn't broken. So we're trying to find the issues before we create them. So let's see how the build's doing. Oh, yeah, it's done. Great. So as soon as that build was done, Cloud Build initiated vulnerability scanning. And the point here is that we're trying to find security vulnerabilities before we deploy them.
Yeah, and the vulnerability scan was super quick and easy to miss, but as you can see in the UI, like it did run, and we didn't find any vulnerabilities. So we're good to go.
So that's great. No vulnerabilities. We're good to go to deploy the image. You can see here, though, that there are some where we found vulnerabilities, and we wouldn't deploy those, obviously. So next, to deploy that image to production, Cloud Build has triggered a Spinnaker pipeline. Google Cloud is a core contributor to the Spinnaker open source project, which makes multi-cloud deployments fast, secure, and repeatable. So what you're seeing here is an actual pipeline in 3 stages. So in the first stage, you'll see we'll deploy a new image, but we'll only route a small amount of traffic to it. And the reason we do this is to uncover the problems. And you can see it's progressing through the stages of the pipeline and turning green. In the second stage, we run automated Canary analysis, where we're really looking for behavioral changes in the image, and we do that to compare to key metrics against the baseline. We've set that to automatically succeed. In the third and final stage, we deploy the image to all the remaining production instances, and 100% of the traffic is routed to it.
Yeah, and in our case, Spinnaker has already finished pushing the new version to production, so we're good to go.
Great. The deployment's complete. Let's go back to Hipster Shop, see how it's doing.
Much faster.
Looks good.
OK, so we can now go back to the IRM dashboard and mark the incident as resolved. That way, all the stakeholders are aware that we've actually fixed the issue. So I think that my job here is done. Thank you, Melody, and see you soon.
Thank you so much, Teo, for helping resolve the issue. All right, there we go. End-to-end DevOps pipeline, including the alpha launch of Stackdriver Instant Response and Management. At Google Cloud, we will continue to collaborate on open source tools like Bazel and Go as we build our DevOps tooling. But part of being an open cloud means working well with the tools and technologies that you already use. Today, we're excited to announce a native Stackdriver Grafana plugin. This lets you choose Stackdriver as a data source from within Grafana, and as a result, Stackdriver users get powerful visualization options. Yay! So with Google-led projects like Open Census, we're making it incredibly easy to extract telemetry from your production apps, no matter what tools you use. And open source tooling is critical for developer productivity, so we're making sure there's first-class support for tools like Jenkins. We also have a dedicated team working with partners like HashiCorp to ensure we have best-in-class support for tools like Terraform on GCP. Let's make this whole ecosystem better together. So today, you saw the alpha launch of Stackdriver IRM, along with how Stackdriver APM tools like Profiler can help you dig deeper to find the root cause of any problem. Profiler just launched to beta, and many of our alpha customers are reporting saving up to 10% of their compute bill with less than an hour of work. You saw fast code search and indexing in cloud source repositories. Cloud Build, automated builds and tasks with vulnerability scanning. Shopify uses vulnerability scanning to scan over 6,000 builds and 330,000 images in the registry every day. Think of that scale. And Spinnaker, automating deployments and providing advanced capabilities like automated Canary analysis. Using Spinnaker, Waze was able to create 1,000+ production deployment pipelines while reducing their deployment errors by over 95%. Businesses like HSBC, Snap, PayPal, and eBay, many more use our DevOps tools every day to ship new functionality more reliably and quickly. We hope you'll try out GCP DevOps tools today. Every developer and operator deserves this level of automation with speed, security, and safety. Let's help you focus on what you love by automating away the toil. Next up, Kelsey Hightower is going to do a deep dive on serverless. Thank you so much, and have a great conference.
That is the longest walk in history. All right, so serverless. What is serverless? Many people define it in many ways. Some people think about it as code snippets running as functions. Some people define it as event-driven architecture. But to me, in watching customers use the platform, serverless starts to be more like a collection of managed services that you actually compose into your own architecture. So what I want to do today is walk you through many of our serverless components in GCP and think like a developer and use these things end to end. Now, I'm going to cover lots of things here. I don't want anyone to get lost. So I have a surprise for you. If you reach underneath your chairs, you will find absolutely nothing. A lot of you fell for that, and I was like, oh, come on. All right, so I'm going to use a bunch of live demos here. So the goal here is that we want to build an application from scratch. And I want you to look at Google Cloud as a bunch of these managed services that you get to compose based on the individual tasks that you want to perform. So we're going to build a very simple weather app, okay? And the goal here is that we can't run any servers ourselves, because that wouldn't be serverless. So I want to build this weather application. And this is a personal app, so I'm going to build a weather application to get temperatures in areas near where I live. So I live in the US, and I have a collection of locations that I want to get weather for. So if you look at these locations, these are states or cities in the US. And here's the thing. I want to take these locations, and I want to call the weather service to get the current temperature. Now, the problem is I can't just give the weather service those location names. I actually need geo-coordinates. So now I have my first task. I want to be able to get geo-coordinates for a list of cities. So I want to take that list of cities and get back something like this, right? Those are the geo-coordinates for each of those cities. Now, instead of doing this myself, standing up a system or server, I'll use a managed service to get this done. So this is where the Google Maps API comes in. I can actually use the Places API, give it those names, and it will give me back coordinates that I can then call the weather service for. All right? Now, you may be noticing a problem here. Neither of these APIs actually emit events for me. So well, the first thing I'm going to think about here is like, I need something to invoke my function that's running in Google Cloud. So the first thing we need to do is think about our data model. We need to store this data somewhere. And again, sticking with this serverless architecture paradigm, I want to use a data store, in this case, data store, that is fully managed for me. And all I need to do is pick a region, and I can deploy my data here, okay? And the nice thing about this is I can authenticate with IAM, so no secrets management, no passwords. Now, the next thing I want to do is actually deploy some code. So here we have what we call our weather data collector. And you'll notice another thing that's really amazing. If you're like me, you're a big fan of that programming language. So we now have Go support in alpha, so you can now write your serverless functions in Go and run them on GCP. You should clap for that because Go is amazing. Now we need to have something invoke our function. It's just sitting there waiting for an event. The weather service is not going to send me a weather event, so we need to manufacture events. So if you're thinking about how do you merge the current world with the serverless world, then you have some work to do. So what I'm going to do is use a product called Cloud Scheduler and actually set up a couple of cron jobs that will tell me the names of the cities every 5 minutes that I need to go and grab the weather data for. So I'm going to go now is go to my weather data folder. The function is already deployed. And I'm going to create a bunch of these cron jobs. So here I'm just going to create a bunch of scheduled jobs. And what this will do is every 5 minutes or so, it will send me an event to my function so it knows to go out and call the weather service. So all of these should be in place, and we'll check out Cron Scheduler. For those of you familiar with App Engine, you'll know this is a service that we typically have for App Engine. We've recently moved Cloud Scheduler to a high-level project, and now you can use it with any compute offering that you want in GCP. So now with these events in place, I need to invoke them. So instead of waiting 5 minutes, I'm going to hit Run Now. So we'll click on these. Events should show up, call my function, and if everything is working, we should end up with weather data inside of our database. So let's just do all of them. Okay, so let's check our database. How many people have confidence there would be data in there? That's not a lot of support. This might not go well. Uh-oh. There's no data in the database. I'm actually kind of like ashamed there's no data in the database right now. So let's see what's going on here. I ran this. I'm actually kind of shocked a little bit. Uh-oh. Data's coming. So we'll keep letting this data come in. Oh, I refreshed my whole browser. So data is trickling in. Now, what's taking so long? This is the first problem with most serverless platforms. They feel like a black box. I have a code snippet running in some platform. I have some event being fired, and I have no idea how long each step is taking. And this is where the observability part becomes really, really important. So what I'm going to do is go over to Stackdriver Chase and reload and look at some of the metrics for some of these function invocations. It turns out some of them are taking 47 seconds plus. This is pretty terrible. Who's at fault? So we look at this, and it turns out the weather service is taking 45 seconds to respond to my request for data. Now, this is not Google's fault, which is great. I don't really believe in blameless postmortems. It's totally the weather gov's fault. But we can totally see all of our data is coming in. So it's a little bit slow on the back end, but we now have all of our weather data. So at least we know what's going on. We have a lot more visibility into the service. The next thing we want to do is deploy an API on top. So the next thing I want to do here is add an API service. You'll notice one thing that's also different here. I'm deploying my entire architecture without worrying about servers being on all the time, okay? Now, normally you would worry about these things being idle and costing you money, and you'll be scaling up and down. In this world, I'm deploying all of my functions, knowing I will only be charged when they're invoked. So I have this weather API. Now you'll notice something here is by default now in GCP, we automatically make all of these functions private by default. So what does that mean? If you try to invoke this function once it's deployed, let's see what happens. You get one of these, right? That's not good, okay? The nice thing about this, though, is someone hits your function unauthenticated, you won't be charged, okay? So we give you some barrier, and we actually do this authentication at the edge. I don't want to expose my functions directly to the internet, so we need something in front. And I also want to think about things like rate limiting, authentication, some more observability, and this is where you need something like an API gateway. And it also turns out Google has another best-of-breed offering for you, and that's going to be Apogee. So what I'm going to do here is I'm going to jump over to Apogee, and you can see here that I have a proxy, and if you haven't seen Apogee yet, you should definitely check it out. It's a service that's pretty fully featured, and one nice thing about Apogee is that once you build your APIs, not only can you authenticate them and get analytics for them, you can also monetize them. How many people like making money? Wow, the rest of you, I'm definitely hiring. So with Apogee, we have this cross-platform management API that sits at the edge. The nice thing about this is if you have things on-premise, GCP and containers or VMs, or using cloud functions, I can use one API gateway to manage it all. Now, I'm going to show you this in action to show you why it's truly amazing and why I'm pretty impressed by it. So not only do I define my API proxy here, but I'm going to show you a few things. One, Apogee has to go and grab an auth token to invoke those functions. Then it needs to put it in its header, and it needs to call my application. There's a lot of moving parts there, but I need visibility to see what's going on. So what I'm going to do here is I'm going to hit trace, and then I can start one of these application traces to actually observe how Apogee is actually implementing all of its policies in line. So some companies have lots of elaborate policies where you're using developer accounts with dedicated tokens. So here I'm going to start a tracing session. So what I'm going to do now is go to the command line and invoke this API using the Apogee gateway instead of the function directly. So we'll go over here to the command line, and we'll just do this to make a little bit more space, and we'll just call curl. So here I'm just going to hit that weather API. You'll notice I have a custom domain. Apogee's terminating my TLS for me, and then we'll see what happens. So we hit enter, and you see we get back a JSON response. But if you look here on the Apogee side, it actually is giving me full visibility into every step in that policy before it hits the backend. And I can actually step through this and get timing information. So we can see the whole request took 204 milliseconds. We can step through and see that our first policy was called, which was to get the private token for the backend function so that it can call it in a safe manner. And then it actually appended that token to the authorization header. And then it went on to make the call. And there's another step that I did down here. So it took 172 milliseconds to call the function. And then I'm also adding CORS headers, so I can do cross-site requests, maybe from a client-side app. But you'll notice one thing about serverless that makes people a little bit uneasy. This is an event-driven architecture. What happens if you want to host a client-facing site? Imagine a client comes to you, and they have 200 millisecond latency. That's way too long. So how are people dealing with this? Well, let's talk about that really quickly. So one way that I thought about dealing with this is pushing all of the front-end logic on the client side. Host it on a CDN, static hosted site, and it will come up fast, and I can call my backends asynchronously in the background. So I'm going to show you my first attempt at doing this. Oh, you guys are hitting my API. Haha, it doesn't work. All right. So now we want to do this front end. Now, there are these legendary people. We call them full stack developers. You know what those are? They can do front end work, they can do back end work, they can do database work. I am not one of those people. I'm more like a half stack developer, okay? I'm really good at the back end. You guys want to see my first attempt at doing front end work? Now, don't laugh, okay? Everyone has to start somewhere. So here's the front end app. Let's see. So we'll go back here to my demo and the weather front end, and let's do this. So it's index.html. Look at that. It's all indented perfectly. All right, so here's the thing. The nice thing about HTML, I can just run it in my web browser, right? So let's try this. So let's open it up and click it. So this is my first site. Now, I was a bit ashamed because it's 2018. I still can't center the web page. So to make myself feel good, I just kind of did that one. It's in the middle. Now, what every respectable developer does in this situation, I'm going to show you guys. Here we go. Okay, there's this site. If you don't know about Stack Overflow, you should. Lots of good production code can be found on Stack Overflow. Now, don't act like you don't use Stack Overflow. If you've never used it before, I'm going to show you how to use Stack Overflow correctly. You ask simple questions like, hey, how do I build a single web page site without a JavaScript framework, right? Because I don't want to bring in the entire internet for a form, okay? I just want some simple thing, okay? So it's okay to ask questions yourself. And this is the internet, so you need to be careful with answers here, right? So there's lots of approaches to this. You can create a single thing, blah, 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 JavaScript, yeah. Ooh, I can use Firebase Hosting. They seem to be smart. And then look at all this code. So there's an example code. It looks great. Oh, man, this is really good stuff. So you want to scan for security vulnerabilities. Just quick glance with the eye will do. And you want to make sure you're copying everything, okay? So you want to make sure you go all the way to the bottom. You want to make sure you do this right. So there's a saying, good developers copy. Hold on, we got to get rid of this. Come on, Vim. This is called latency over SSH terminal. All right, and we'll get here. I. Great developers, paste. So we're going to take the suggestion from Stack Overflow that we should use something like Firebase Hosting to host our site. So if we go to Firebase, we'll see what it offers. So Firebase Hosting is another Google Cloud product, and it's really aimed at supporting developers who want to really focus on their code and nothing else. All right? So we'll go over here and we'll take a look at what it does. So the goal is we can produce our static content hosted on Firebase, and it will distribute all of those static files globally for us so that our customers can have a very fast experience. So we've just copied this code from the internet. The only respectable thing to do is to deploy it to production. So here we'll do Firebase and deploy. You don't need to look at it again, it's fine. You put it there, and then we should deploy it directly to production, okay? So now that our code is there, pretty sure everything is safe, and we should go to the Firebase console now to see that it's been deployed. Now, if I point a CNAME to Firebase, I can have my own custom domain giving me kind of this vanity URL, and if I click on this, and within a few seconds, Firebase actually has that website deployed. And if you've noticed, there's a small snippet of JavaScript in the background that's calling the Apogee endpoint that's loading the data. So from a latency perspective, your customers don't have to be aware that you're using this event-driven architecture underneath, right? You can kind of preserve some of that performance you were looking for. Let's click through this just to make sure it works. Now, you get to focus on business value. You get to focus on building cool things for your company. Web pages are so last month, okay? If you can't talk to your website or application, you're not quite there yet, okay? How many people can ask their website questions? This guy can, and 2 other people are lying. So I'm going to show you how you add this functionality to what you have. So we have this simple weather app. We have an API. We have a web front end. Now we want to start to be able to do things like ask Google questions. So as a developer, we've taken all of our machine learning and given you a very friendly API you can use with a product called Dialogflow. This is another cloud product. And with Dialogflow, you can actually express conversations, capture users' intents. We do ML training our custom model for you in the background, and you can hook up that directly to wherever your API are running. Now, for the sake of time, I have this running in Apogee, my Google Assistant cloud function. So if we go over here to our functions, we'll see the whole stack deployed. So we'll go back here, and what you'll see is my whole stack that's actually deployed inside of our setup. And these three functions equal my kind of service architecture. Each function does only one task. They only have a very specific set of security credentials, and that way it's a little bit easier to control and orchestrate what I want. So let's go ahead and build out our Dialogflow service. We only have a few more minutes, so we're going to try to wrap this up as quickly as we can. So we'll log into the service. I'm going to show you how you add Google Voice integration or Google Assistant integration to your existing properties. So here we define a set of intents. And what this is we want to be able to give the model a few expressions you think your customers will ask you. So in this case, I give it a free examples, and then it will actually be able to figure out what our customers want. So in this case, they just want to ask what the weather is. So once we have this, we hit save, training will go on. We can do a little bit of integration work, and I'll show you this piece really quickly. So on the integration side, we go here to our fulfillment process, and we point it directly at Apogee. There's an API key. It's good for about 30 more seconds, so do what you will. And we can integrate it to the Google Assistant. Now, once I have the Assistant up, I can actually start to emulate any Google devices that support the Assistant, whether it's my Pixelbook, or phone, or Google Home. And then we can start to exercise this. So how many people have great confidence that this will just work? It's not a lot of hands. I like the applause. All of you that are in favor of this working, you have free Gmail for life. I don't know if I can legally say that. So let's talk to the weather service.
Getting the test version of local weather. Hello, Kelsey.
Ooh. Hello.
Looks like you have a pretty large crowd here. I hope the demo gods are on your side.
Me too. So let's ask it a question. So what's the weather in Portland?
The current temperature in Portland, Oregon, USA is 51 degrees Fahrenheit. Okay, I gotta admit, that was pretty dope.
So as you can see, on Google Cloud Platform, we have many different brands and services and products. I can use Data Store to store my data efficiently without thinking about the database. I can use Cloud Functions to host my business logic in little code snippets, and now we make it available in Node.js, Python, and Go is now in alpha. You can use things like Apogee as an API gateway to add policies on top of your APIs and even monetize them when you're ready. And then you can add new things like static hosting using Firebase. And then if you want to really spice things up, you can use the Google Assistant to automatically give a voice to your applications. And with that, thank you. Back to you, Eva.
Wow, what a morning. And Kelsey, that was 1 hour show. I really like that demo. Great developers copy, right? So we have been through infrastructure. We have been through operational software, DevOps, and as Melody said, to create your elite DevOps team now. At Google Cloud, we are committed to bring great things together, taking inspiration from customers and listening to their needs, whether it's engineering to engineering, open source forums, or company-wide engagements with our customers and partners. So following Kelsey's talk, I really want to show you one more last customer before we close this one, and it's Ubisoft. They are the makers of games like Assassin's Creed, Just Dance, and Far Cry 5. We began working with Ubisoft some years ago, helping them to bring to the web some of their best-selling console games. But lately, we've become involved with something much larger and richer that is really exciting. So to talk about that, I'd like to welcome on stage Pierre Miesga, Project Director of Ubisoft. Round of applause.
Thank you, Eva. I've always considered hieroglyphics as mysterious, almost magical. And when you think about it, what we can do with machine learning today, well, it's pretty magical too, right? The story begins with a video game franchise which conquered the heart of more than 100 million players in 10 years, Assassin's Creed. Since the first game, released in 2007, Assassin's Creed has always been designed to immerse our players into historical eras with worlds as realistic and believable as possible. In 2017, Ubisoft released the critically acclaimed Assassin's Creed Origins, set in ancient Egypt. To create this game, we collaborated with the Egyptologists to ensure that everything was as accurate as possible, from the buildings and the culture right down to the hieroglyphs featured throughout the game. Now, at Ubisoft, as a video game company, our goal is to entertain, right? Actually, more than that. Our wish really is to enrich people's lives. That's why, more than developing a video game, we became convinced that we had a role to play in research. That's what pushed us to create the groundbreaking Discovery Tour, a free educational mode for every Assassin's Creed Origins players. As we were working with Egyptologists, we developed a greater understanding of the way they work and the many challenges they face. You see, while digital humanities technologies have revolutionized many academic studies, the process of translating hieroglyphics is time-consuming and remained virtually unchanged in over a century. Well, at Ubisoft, as a tech company, we believe that AI is a technology that has the power to help people in their daily jobs and in their lives. So together with Google, we started working on the Hieroglyphics Initiative, a research project meant to identify how machine learning could help with the translation of hieroglyphs. Our goal? To give Egyptologists more tools to help in their daily jobs and to identify the potential for machine learning, leveraging GCP products such as AutoML. So we started the project by studying the steps Egyptologists go through in the process of translation. First, glyph outlines were extracted from source material, then sequenced. Once they were in a sentence, they would be identified, analyzed, and finally translated. So we tackled the challenge in the same way. However, we soon discovered that there were not many sources of data out there to train the machine learning model. So what do? Well, we asked the internet. We invited our players to join this experiment and crowdsourced drawings from Assassin's Creed fans using Firebase to create our first training set with more than 80,000 glyphs in a single night. However, working with more than 800 different glyph shapes is a real challenge. Why? So that's when we turned to AutoML, which enabled us to create our first models for recognizing hieroglyphs. We have packaged this and other time-saving features into a Google Cloud project which anyone could use. This is all connected through the Hieroglyphics Initiative Workbench, a browser-based tool that can be used for a range of Egyptology tasks. It also captures data and thus improves the machine learning models over time. So the feedback we receive from academics and institutions around the world is already very encouraging. But this is only a stepping stone. We have built this platform so it can continue to grow and improve by making all tools and data open source by the end of this year. Our wish is that the Hieroglyphics Initiative will have a long-lasting legacy and be the basis for more innovations in the study of Middle Egyptian, such as research, teaching, or as a data repository. And we'll keep supporting it on the long term in collaboration with our friends from Google. As Ubisoft, we will continue to push the boundaries of video games and invite everyone to join us in this journey. Thank you.
Thank you. Thank you so much, Pierre. Isn't that really, really exciting? And actually something that now is brought into the schools, leveraged by teachers to taking this forward. Having this 5,000-year-old language into a living feature in your game is a really unexpected way of thinking about innovation. It would add to the gameplay and would really raise the status among customers and developers. And with that, we're done in here. Now it's time for you again to go back, take the stage on the show floors, looking for your golden nuggets when it comes to the next breakout sessions. And I'm so excited to have you here. Have a great continued day. Thank you so much. Bye.